what? That is muted so that it doesn't have any feedback. So if you are in the building needing chemistry help, go ahead and put a purple heart in the chat box. If you are needing help and you're on this live, put a purple heart in the chat box, okay? We love interactions here over here on Professor TK the Chemist page. We love feedback. And we love when you guys interact with us too. Okay. So what I'm doing now, all right. So yes, Evie. All right, Evie. All right. Very good. Very good. All right. So let me go ahead and screen share. Okay. What we were talking about yesterday, we were dealing with, of course, reviewing for the final exam because so many of you all are excited and anxious to get this part of your life over with. So I get it. I think taking a chemistry exam is like going to the dentist. You're nervous, but it's something that you got to do. And that may not have been a good example, but hey, this is something that many of you all are going through right now this semester. And I want to make sure that I help you guys get what you need for your chemistry test, okay? So, for those of you all that don't know me, my name is Professor TK the Chemist. I am a chemistry college professor. I've been teaching for over 25 years. I am not new to this. I am true to this. Many of my students come to me because they know they can. I have an open door policy. If you need help, let me give you the answers. Let me help you out with that. Many times, students are afraid to go to their professors because they don't know, hey, one, how to communicate with them, because some of your professors do come across as being very intimidating. But as I always say, it's all good. You got to ask even when you're afraid. Closed mouths don't get fed. So you want to make sure that if you have trouble before the semester ends, you want to go to them, and you don't have to beg, no, but I do recommend that you go and consult with them if you're having problems, okay? So, yes, Evie, I will do molar mass calculations today. Matter of fact, that's one of them that we're going to actually hit on today. I don't have worksheets per se, Rosa, that I can actually give you right now. But if you want to get a copy of this video, you can always go to the YouTube channel and you can hit the link in my bio and it will take you straight there to my YouTube channel. And thank you guys so much for the follows and for the shares. Guess what, guys? We are 4 people away, 4 people away from having my 10,000 supporters. I don't like to say followers because it's like, it just sounds so, you know. But I just call you guys my supporters because you're not following me like that, but you're supporting me. Okay. So I appreciate all of the love, the hearts, the follows, all of that. I really do. And this is why I go live every day, Monday through Thursday, 12:15 Eastern Standard Time. I used to go live at 12, but now as we're getting down to the wire, I've changed my schedule a little bit because I'm doing some office hours with some of my other students. So at this time now, I'm going to go ahead and get into this first problem. And if you guys can, just continue to hit that screen, hit it, because that's going to let everyone know that we are in the building giving away free tutoring. We're doing a free study hall session on General Chemistry 1. So this particular time period is dedicated to my General Chemistry 1 students. Now, I know I may get some General Chem 2 students coming in, and that's fine, but I just ask that you have patience with what we're going through right now in terms of the lesson that I have at hand. All right, so if you guys are ready to get into it, I am as well. Let's get it. In this first problem, when we're talking in 59, we're going to look at question 59, okay? When they are talking about how many moles of something is in a formula, okay? How many moles of something is in a formula? What you have to keep in mind is that Avogadro's number plays a role in some of what you're going to deal with, okay? Avogadro's number plays a role. Excuse me 1 second, guys. Excuse me. Okay. Thank you, Kimberly. I appreciate that. You're going to do well. Just remember everything that your professors or your teacher has told you, and you will do just fine. Listen, make sure you answer every question and make sure that you don't panic on questions you don't know. Just put a little tick mark by it so that you can come back to it. Okay, so what we've got on the board is a mold problem. And I know a lot of times in chemistry, some of you guys panic when it comes to molds and molecules and trying to find all of that good stuff. So what I'm going to do is show you all how to do these types of problems, okay? If you have questions, of course, I got you on the answer. I got you, got you. Okay? So let's go ahead and start with this first problem. For number 59, it says 1 mole of copper 2 sulfate contains blank moles of oxygen. So you've got to figure out how many moles of oxygen you have within your problem. Who thinks they know what to do with this particular problem? Like, what do you have to do in order to find this answer? What should you do? Let's figure this out, okay? Let's figure this out. Gotta move this out the way. Now, and I know some of you guys have been asking me about answer keys and study guides and all that good stuff. And the thing is, if you're in a chemistry class, you should have plenty of work that your teachers have given you, plenty of study guides that you can actually utilize. Okay, you should, well, at least hope you do. Yes. So in this first problem, number 1, it says, how many moles of oxygen do you see? Well, take a look. Take a look. I see 1 copper mole, 1 sulfur mole, 4 moles of oxygen. Okay. So each of those individual elements gives you the moles that you see for that particular problem. So within that formula that we have here, you're going to simply say 4 moles of oxygen because of that subscript right there, okay? Because of the subscript. All right. Number 16. See, we've been working on this particular study guide for the past 2 days. We've been working on it for the past 2 days. So we're almost halfway. We're actually a little over than halfway there. All right, so let's take a look at the next one. Number 16, find the molar mass of magnesium chloride. So the first thing you have to do when you're trying to find the molar mass of a certain element, okay, or compound, you're going to look at your periodic table and you're going to find the molar mass. So on your periodic table, there are elements that have decimals in them. That's the mass for said element. So magnesium has a mass of 24.31. And since I have one of those, I put 1 times 24.31. For chlorine, in my formula, I have 2 chlorines. So I'm going to say 2 times. And when I look at my periodic table, the mass for chlorine for one of them is 35.45. But since you have 2 of them, you're going to multiply them. Now I'm going to go ahead and add these 2 numbers together. So I'm going to multiply. Thank you, Francesca. I hope I'm not slaughtering your name. Thank you so, so much. And how are you doing today? So you've got 2 times 35.45, and you get 70.90. Now, all we're going to do, guys, is just add that number to 24.31 to give us 95.21. 95.21 grams per mole. Fantastic, fantastic. Thank you guys for those roses. I appreciate that. So you get 95.21 grams per mole. So this answer here, letter B, is the answer. Now, here's the deal. Here's the deal. You'll notice, let me show you all how to do process of elimination, okay? So what you will find on your test, Sometimes your professors will give you the mass for just magnesium, and that's why you have to cross that one out. They'll give you the mass for chlorine. You have to cross that out. So you've got to remember that anytime you are looking at your problems and you're trying to establish the weight, you've got to consider every element and their subscripts. Also, for 59.76, they're giving that answer if you forgot to double your chlorine. So I'm just showing you all tips and tricks that they use on these tests when they're showing you how to get rid of answers that don't make sense. If you have 5 answer choices, like this particular example, there are 3 that are obviously out of this world. There are 2 that are close to being possibilities. So you always want to look at the answers to establish what can I do to get rid of the answer choice that doesn't make sense. Okay? Good job, XR. Good job. Fantastic. You passed with a B. Thank you, Rosa. Appreciate that. All right, let's get on down to the next problem. You know, most of the chemistry exams that I do, I tend to put them in the order in which we utilize the information during the semester. So this particular test is going in that order, okay? So this particular study guide that I have is going in the order of what we've learned. That means it's building up to the end. So it's setting you up for pre-steps to kind of give you clues on what to do for the next type of problem. So for this one, for number 61, it says how many grams of Fe2O3 are there in 0.500 moles of Fe2O3? Okay, what do you have to do first with this problem? In order to convert moles to grams, you need to calculate the molar mass of your problem. In this case, it's Fe2O3. Okay, so you've got to find the molar mass of Fe2O3 for whatever compound you're dealing with. So I'm going to write that here in this space right here so that you all can see how I'm going to solve that part. So Fe, you have 2 of them. For oxygen, you have 3 of them. You're going to multiply each of them by their respective molar masses. Iron has a molecular weight of 55.85. So that's why I'm going to say 2 times 55.85 because I have 2 of them. And then for oxygen, the weight for oxygen is 16.00. So I'm going to multiply both of those as well. And now let me go ahead and get iron's molecular weight. So that's 2 times 55.85, and I get 111.70. All right, you're going to add those 2 together to get your weight, okay? And you get 159.70 grams per mole. Now, here's the deal. What you're going to do, good job, it's Justly. You're going to do very well. You're going to do very well. As long as you've been studying, you're going to do very well. So now what are we going to do? We're going to go back to our problem. Because we're trying to convert the moles of that number, 0.500 moles of Fe2O3 to a gram, what are we going to have to do? We're going to have to take the number that they gave us right here, 0.500 moles of Fe2O3 times. Because you're trying to get to a gram, I'm going to put that 159 on the very top of Fe2O3. And on the very bottom, 1 mole of Fe2O3. And guess what? You're going to cancel those bad boys out, the moles that is, because we don't need moles anymore. And so now all you have to do is multiply those 2 numbers. So you're going to say 0.500 times 159.70. And you get 79.85. Oh, good job. Good job. Yes, you want to go over equilibrium problems? Okay, I'll see what I can do for you. Hang around and I'll get you in about 10 minutes, okay? Yes, Amy, you are using dimensional analysis on this problem, and it's just a one-step problem. So here we go. Yes, Big Z, I sure do. I've been going live every week, Monday through Thursday. At lunchtime, I call this lunchtime chemistry. I've been going at 12 noon, but now for this last 2 weeks, I'm going live at 12:15. 12:15. Yes, yes, yes. So we got this answer here, okay? Okay, Diana, I will get your question. You said, how do we remember to know to put 1 mole over that? Okay, good question. Let me go ahead and get this answer here. I'm going to erase some of this stuff so I can get some more space in here for you. Okay, so we got our answer of 79.85. But remember, we only need 3 of those numbers. That means this 8 turns into a 9. And this is what we have right here, 79.9 grams. Okay, and I don't know why I put grams per mole. that was a slip up right there. It should just be grams. Okay. So let me go ahead and break down for you, Diana, how we got the grams over the 1 mole. Okay, here is the deal. And let me go ahead and erase some of this stuff right here. Okay. And I'm going to give you a tip, a quick tip that is, on how to know when to do it. Okay. Whenever you're going from a mole to a gram, your molar mass calculation that you get, I could say 159.7 grams of Fe2O3 over 1 mole of Fe2O3, or, hold on 1 second, let me erase the rest of this, okay? Or I could say 1 mole of Fe2O3 over 159.7 grams of Fe2O3. The difference is what I'm trying to get to. So in this particular case here, because I'm trying to get to a gram, I have to put that particular conversion factor on the very top because I'm trying to get to a gram. However, if I were trying to convert to a mole, I would use this one instead. So whatever type of conversion you're trying to get to, that determines which one goes on top. So if I were to flip this problem and say, how many moles of Fe2O3 are there in 0.500 grams, then I would take the 0.500 grams on top, okay, right there to start that number. On the very bottom, I will put the molar mass, the 159.70 grams, and on the top, 1 mole, okay? Oh, you're welcome. You're welcome. So whatever you're trying to get to, that conversion goes on top. Whatever you're trying to get away from, you slash it out and put it on the bottom. Yes, thank you guys so much for those compliments and understanding. Yes, thank you, thank you, thank you. Okay, the in-depth, I'm messing your name up, honey, but you said, are grams understood rather than any other unit, same milligrams? Well, okay, so I think, let me make sure I understand what you're saying. Okay, let me make sure I understand. Now, if you're saying grams, yeah, grams is the G stands for grams in chemistry. Mg stands for milligrams. Dg stands for decigrams. Yeah, so the G is understood to be a gram and not anything else. I don't know if that's what I'm answering your question, or maybe you could say it a different way. Okay, yes, yes, yes. Okay, I got you. Big Z said, where do you teach? I need you. I'm virtual. I'm virtual. Yes. You know what, y'all? The reason why I make everything so simplified is because when I was in undergrad many years ago, this type of stuff was so difficult for me to understand. And I knew that once I became a teacher, I was going to make sure that my students understood it way better than what my teachers did. So I learned the easier methods without all the extra jargon. Yes, edible path. Yes, yes, this is for grams and moles. Yes. So whenever you're doing a conversion from grams to moles, or moles to grams, yes, you have to use the conversion factor where you are saying, and let me use a different color. If I say 1 mole of whatever it is, it's always going to equal to the grams of whatever that is. Okay. I got you, the indelible path. I got you. Okay. Now, let's take a look at this next problem. Okay. You're welcome. Yes, Amy, that is correct too. Now, if we take a look at number 62, appreciate that. I'll be trying. I'll be trying. Whenever it comes to balancing your equations, okay, and because this is I know, Diana, you know what? I'm gonna tell you right now, if I could pull up my students' grades, I would. Many of my students pass my class with flying colors, and I'm not just saying that. I am not just saying that. I have been awarded and nominated so many times, but I've been awarded the Excellence in Teaching Award twice in my 25 plus years. And that's because I relate to my students' struggle, because I was a student at one point. I've been where students are trying to go. And I don't understand why some of my colleagues make things so difficult. I don't understand that. I don't. Oh, thank you, local Mimo. Appreciate that. I love y'all's little names. Yes, thank you. Thank you. Look, y'all can go check me out on my website. Y'all can see what I do. Yes. And I say teaching is a calling. You can't do this because you want to get paid. Because y'all know, uh, look at what they're doing now. They are laying off teachers in so many states. I'm like, for real though. Why? But yeah. So when we get to 62, they want you to place the coefficient in front of oxygen. Now, polar and non-polar. Okay, I think I may have some problems for you, Amy. Give me a sec. I bring it back up in about 2 minutes. Yeah, I think I got a problem or two I can do for you about polar and non-polar. Yes. When it comes to balancing your problems like this one, okay? Notice that it's halfway balanced, right? It's already balanced to a certain extent. Here's what you're going to do. You're going to, matter of fact, well, no, I'll keep it right there. Those birds are chirping today. I love listening to Mother Nature. Okay, but anyway, yes. So whenever you're trying to balance out these equations, what you've got to do, since this was halfway balanced, what I want you to do is to look at carbon. All right, you've got carbon, you've got 5 carbons on the left. There's already 5 carbons right there on the right. Then you go to your hydrogen. So you balance carbon first, then you balance your hydrogen second. Then you balance your oxygens last. Okay? So what I'm going to do is show you all what's next. Notice that you have 8 hydrogens on the left. You also have 8 hydrogens on the right. Now, when it comes to your oxygens, you've got to look at what you've got here in terms of your total number, okay? On the right-hand side, because that's the one that you're trying to balance. So right here, I've got 5 times 2. 5 times 2 for my oxygens is 10, plus 4 times 1. 4 times 1 is 4. So I get a total of 14 oxygens on the right-hand side. Well, what number times 2 is going to give me 14 oxygens? The number 7. Okay? The number 7. And there's your answer right there, letter D. Okay? Letter D. So again, when it comes to balancing these equations, you don't have to overthink it. You don't. I promise you, you don't. Let's look at the next one. Even though they want you to classify this reaction, I want to first show you if it's balanced or not, okay? Let's count those sulfurs. You've got 1 sulfur on the left, 1 sulfur on the right. Boom. 3 plus 1 oxygen here gives you 4 on the left. You've got 4 oxygens on the right. 2 hydrogens on the left, 2 hydrogens on the right. This reaction here, guys, is balanced. Now, we want to know, what kind of reaction is this? This is a combination reaction. And how do we know? And in some books, we'll say synthesis. How do we know the difference? Well, as a review, if you have A plus B giving you AB, that means you have an element plus an element giving you a compound, or you could have compounds plus compounds giving you, one single compound. So it just depends on what you got. But if you just look at the example or the this way of doing it, you should be able to know the difference. Now, let me show you what happens if I flip this and say AB goes to A plus B. This would be a decomposition reaction. So if I flip this and reversed it and put H2SO4 first, followed by SO3 and H2O, then that would be a decomposition reaction. Okay? All right. Now, take a look. Let's move on. I'm just going to go at random. Someone asked me about polar and non-polar. So let's talk about, okay, what would a combustion equation look like? Marina, guess what? This right here is a combustion problem. This one. A combustion problem. Let me zoom in a little bit so you can see what I'm talking about. A combustion problem means you're going to have some hydrocarbon element plus oxygen producing carbon dioxide and water. All right, here's the deal. If you see water and carbon dioxide on the right-hand side, meaning the product side, that is your combustion problem. That's right, Amy. Combustion makes carbon dioxide and water, always. You're welcome. I'm going to show you another example too on a double displacement or replacement reaction, okay? So even though 64 is asking you something completely different, it says, which of the following is an oxidation reduction reaction? Let me at least show you some examples of, double displacement, okay? Double displacement is pretty much A, B, D, and E. Why those double displacements? Because you basically have this compound plus this compound producing 2 new compounds, okay? So with double displacement reactions, it's like you have compounds plus compounds producing 2 new compounds. Yes, I will be doing reviews next week as well. Monday, Tuesday, Thursday. I sure will. I won't be able to go live on Wednesday, but I will be Monday, Tuesday, and Thursday. Yes, yes, yes. Hey, Leo. Well, I don't have these questions to give you. I wouldn't have a way to give them to you. But if you need this type of study guide, listen, you can Google, final exam chemistry reviews. You could also Google, like, whatever problem you're having issues with. You can say study guides for, let's say, chemical reactions, study guides for acid-base reductions, study guides for molar mass. Thank you so much. Thank you, thank you, thank you. All right. So I'm going to go ahead and randomly go through another problem for you all, okay? Because I know some of you all are still wondering about stoichiometry. I like saying the word stoichiometry. Stoichiometry, okay? And I know, matter of fact, I'm gonna go back up. Oh, but someone had asked me about um, polar covalent and covalent compounds. Okay, let me go ahead and hit that real quick. Pause. Let me grab an example for you, okay? So when it comes to polar and covalent and ionic bonds, here's what you got to remember. Covalent simply means non-metal plus non-metal. And you use numerical prefixes in the name. Okay, you use numerical prefixes in the name. Ionic bonds, on the other hand, is when you have a metal plus a non-metal. They swap charges. These do not swap charges, okay? Covalent bonds do not swap charges, but ionic bonds do, okay? So when it comes to polar covalent bonds, okay, listen to the keyword covalent. That means you have non-metal plus non-metal, right? But if I say polar covalent, what does the North Pole and the South Pole do? They're opposites. One is positive and one is negative, but they're both non-metal elements. So as an example, that means hydrogen and chlorine. Hydrogen behaves like a metal, but it has a positive charge. It is a non-metal element. Chlorine is a non-metal element. So when you think about polar covalent, they're both nonmetals that just so happens to have one of them being positive and the other one is negative, even though they do not swap charges. Ionic bonds, though, one is a metal, the other one is a nonmetal, and they do swap charges. I hope this helps the person that was asking about polar and nonpolar. Okay, gotcha, Amy. Gotcha. Okay. Yes. Oh, Driva, you asked a very good question. Okay, and K Rich, let me see what you got. Z, I do not do organic chemistry. 54, yes, the answer would be um B for that one. It would be B for 54. Hey, Toya. You are new to chemistry. When are you done with your semester? I know students are taking chemistry at random times of the year. So if you're new to me, I've got a lot of information on my website. I have over 100 videos that you can actually go and take a look at. But what do you want to know, Toya? Okay, and Driva, I got your question too. Let me see. Can you explain polar bonds and nonpolar sharing equally or unequally? Okay. So with polar bonds, that's when it's a covalent bond in which you have one or more pairs that are shared unequally. Okay. So polar, I'm gonna put CB just because of space. Polar covalent bonds are basically sharing unequally. Okay. They're shared unequally. And then with non-polar covalent bonds, they are shared equally. Okay, so non-polar covalent bonds are shared equally. Okay, Toya, I got you. All right. Thank you, Bino Tag. Thank you. Okay, give you an example. Okay. All right, let me see here. Let me give you an example. Let me give you an example. You know, I stay with my examples too. Okay. So chlorine attached to chlorine. Okay. Yes, Haley, you can think of it that way too. That's right. Ray, I've been trying to go live in the evening time, and my schedule is kind of like, well, can we get you in? I'm going to see. I may go live tonight. Yeah, I may try to go live tonight. When it comes to nonpolar bonds, for instance, you have to also think about the electronegativity values for these elements. So if you look at, let's say, chlorine to chlorine, okay, that would be considered a nonpolar bond because in this case, they are sharing the same things equally, okay? Equal amounts. But if you look at, let's say, HCl, hydrogen and chlorine, they are not sharing them equally because hydrogen is coming in with one valence electron, and chlorine says, well, let me go ahead and get your 7. Or let me contribute my 7 to your 1. Yes. So when it comes to your polar bonds, you have to remember they are unequally shared because one of them is positive and the other one is negative. But with shared equally, it's usually your diatomic molecules also. Another way to look at it. Your diatomic molecules are another way to look at your nonpolar bonds. That's right, Haley. The goal is to be stable. That's right. Yes, that is correct as well, Dreva. Excuse me. Yes. This plays a role. This particular chapter here of polar and non-polar bonds, that plays a role. Let me show you. I'm gonna pull up an example because you guys are asking some really good questions. Whoops, this. No, you're not shy. No, you're not. No, you're not. Don't claim that. Don't claim you're gonna fail. No, you're not. Take those words back. This plays a role in, I may have one down here. Oh, when it comes to drawing these Lewis structures like this. Okay, Sina says, so H2O is non-polar. Okay, let's take a look at that. Let's see. Let's see. Let's see. And a lot of times when I do these examples too, sometimes they can be a little tricky. Okay, they can be a little tricky for a number of reasons. So let me go ahead and answer your question. If you look at water, okay, it actually is a polar bond. And I know you're like, wait, what? Because remember, water is positively charged, oxygen is negative, and then there's that other hydrogen there. So you can actually think about the bonding process here, okay? Even though hydrogen is a nonmetal element, and so is oxygen, because of the charge, this would be classified as a polar bond. Thank you, Rosa. Thank you, thank you, thank you. Okay, Driva. Now that question that you wrote, is that the formula that you're looking at? H-NOF? Cena, you can look at it, but you know what? Let me tell you. Ugh. Okay, Kiki, you hold your question, honey, because we're dealing with polar bonds. So you hold on, honey. Hold on. I'm gonna get your Kelvin question in a second. Okay, for hydrogen bonds. So yeah, let's break this down again. Okay. When it comes to hydrogen bonds, hydrogen is one of those weird elements because even though it's in group one, it's a group one element. Okay, it's the first element on the periodic table, and it's on the metal side. It's actually a non-metal element. So when you talk about polar covalent bonds, you got to remember in this particular case, the charge, yes, will tell you to a certain extent what it is, especially when you're talking about two non-metal elements. Okay, two non-metal elements. So I was saying for hydrogen bonds, you mean hydrogen attached to itself, Driva? So if hydrogen is attached to itself just like that, then in that particular case, it's going to be a non-polar bond because it's attached to itself. Like anything that's like a diatomic molecule, chlorine, bromide, iodine. Diatomic molecules are non-polar molecules because they are attached to themselves and they consist of two non-metal elements that are joining together by a covalent bond. Yep. Joining together by covalent bonds. Okay, where's my friend that said, how do you get Fahrenheit when you have Kelvin? Do okay, are you in chemistry right now? And the reason why I asked that question, see, some of these problems when you're asking about temperature and all of that good stuff, you've got to simply remember the formula. That's all. Ooh, Mariana said perfume. Okay. I don't know the value of the perfume, but okay, must be something nice. Real nice. Okay. So you want to know how to get okay. Now I know when you talk about Kelvin and Fahrenheit, let me erase this part. Well, okay, but Shy, you add 273 to find Kelvin if they give you degrees Celsius. The person was asking about Fahrenheit. Yeah. First, you would want to take your Fahrenheit and convert that to degrees Celsius, then convert that number to Kelvin. Okay. No, I haven't done stoichiometry yet. I'll get to that one too. Oh, Taylor, good question. That is correct. Then they are non-polar. Right, they are non-polar. If the question was if they have the same electronegativity, are they non-polar? A perfect example is fluorine. Fluorine is a diatomic molecule. And it's the most electronegative element on the periodic table. And because it's itself, it's non-polar. Diatomic molecules are non-polar bonds. And this also appears in many chemistry textbooks in terms of the chart. Okay, I hope you did very well. No, I haven't done that one yet. Orbital configurations yet. No. You guys are asking really good questions. So let's do one then. Let's since I have the screen up for it, let's do this one, okay? So I'm gonna do number 98, okay? They want to know what is the correct structure for PI3. Well, remember, one of the things you have to do whenever you're doing Lewis dot structures, okay, PI3, you've got phosphorus and you have iodine. You've got one phosphorus, but you have three iodines. So I'm going to multiply both of those by their respective valence electrons. The group number tells you the number of valence electrons you will have. Phosphorus will have 5. So that's 1 times 5 to give you 5. And then iodine has 7 of them each. So that's 3 of them times 7 to give you 21. So you add those together and you get 26. Phosphorus obviously is going to go in the middle, surrounded by 5 valence electrons. So what I'm going to do over here in this space, I'm going to show you before we tell you what the answer is. Okay, let's go ahead and draw out phosphorus in the middle with those 5 valence electrons. This is 1, 2, 3, 4, and 5. Now, remember, iodine is coming in with 7. Okay, they're coming in with 7. So when you put on the first element, start at the very top instead of right beside it, because you don't know if it's going to form a double bond or not. So that's 1, 2, 3, 4, 5, 6. And I'm going to put the 7th one up at the very top. Here's the next iodine. 1, 2, 3, 4, 5, 6. And I'm going to put the next one right there. That's the 7th one. And here is the last one. I can start there and say 1, 2, 3, 4, 5, 6, 7. And as you look at your image or your structure here, you'll notice that all of them have a total of 8 pairs of or valence electrons around them, including the one in the middle. So because of that, your picture is going to look like this one right here. Now, it doesn't matter if I put it on the top or the bottom. The iodine could have been on the bottom or it could be at the very top. It doesn't matter, okay? So this is your picture, and what they should have also done is shown the extra 2 little dots there, but they didn't. But this is your picture right here, okay, for PI3. All right, guys. Okay, now someone asked me about stoichiometry. So for those of you guys that are on YouTube, as you will notice, this is a random based study session that I do every day now for the next week, because so many students need reviewing on different topics. So if you're on YouTube watching this, if you're on TikTok watching this, you'll notice that I'm doing random problems, but you can always go back and look at the video, again on YouTube. Okay, I keep these lives up so that you guys can go back. All I ask that you do is do what? Follow and like the video. That's it. Nothing more. Follow and like the video. My YouTube page is Learn Chemistry with Professor TK the Chemist. Learn Chemistry with Professor TK the Chemist. All right. Now, Shai said, can I do the gas laws? Okay, yeah, we could do one. And somebody also asked me about stoichiometry. Let me see. I don't even see the... Okay, user 2523, are you still here? 2523? I know you wanted that. And Diana said also stoichiometry and limiting reagents. Okay, I got you. Someone said more orbitals, please. Okay. So here's what I need y'all to do, because I'm going to forget. If y'all can go to my last video, type all that down, like just put that topic, just put those topics on my last video, so that what I can do is go back and either make videos particularly for you, or I'll do it on my live. But I got a feeling I need to go live tonight also. I'm gonna see. I'm gonna see. Yes, Shy. On my last video, yes, yes, yes. If you could just put what other topics and subjects you want me to go over during these next couple of review sessions. Oh, and if y'all can, tell me this. What chemistry are you taking right now? Because see, that's also going to help me. I don't know if I have a lot of General Chem 1 students or General Chem students, because a lot of times I am putting everything here. Yes, excluding the pen one. Yes, excluding the pen. Just my last video. Oh, congratulations, Roman. Okay, Faye says Chem 100. All right, principles of Chem 1. Okay. Okay, show how I got you on that. Okay. Michelle said General Kim 1. Okay. Yes, Robin, the answer is A. Okay, Diana Gala says you're taking the intro to chemistry. Okay. Chem for engineers. All right. IB chemistry. Okay, so you guys are in a lot of different chemistry levels, and that's all based on what we're doing right now. Now, if y'all want me to continue to stay on this live, I need y'all to keep hitting that screen. Tap it up, tap it up, tap it up. Please tap, tap, tap. So that way I can see what y'all need to do. No, Shohag, I don't do any lab techniques. No, at least not during the live anyway. Yeah, thank y'all so much for hitting those hearts up. That's also gonna make everyone on TikTok know what we're doing over here. Okay. Thank y'all so much for the follows and for the likes. I really appreciate that. Because you know what? Listen, I don't ask for a dime. The only way I get paid to do this is if you all hit the link in my bio and you want one-on-one tutoring. That's the only way I get paid for this. Other than that, only thing I want y'all to do on these lives are to just tap the screen. Okay? Tap the screen. That's how I get the love doing that. Okay? Thank you, thank you, thank you. Faye says you're stuck on how to do valence electrons. Okay, honey, let me go ahead and pull up a periodic table for you because that's what's going to help you also. Let me do this. Let me switch my screen over. Okay, so I'm going to switch my screen for YouTube. Okay, so let me do that for you real quick, okay? Valence electrons is based on your periodic table group number. So let me find a picture I can put in here for you. I'm going to pull up a periodic table for you right now. Okay, and you're struggling, Kiki, with naming compounds. I got you. And then Kiki Keisha, my YouTube page is Learn Chemistry with Professor TK the Chemist. Learn Chemistry with Professor TK the Chemist. Let me see if I can find my favorite periodic table that I do whenever I pull it up. This is not the one. Hold on, y'all. Okay. I'm just going to pull up a periodic table to address that concern of, oh, there's my favorite periodic table. Y'all, I like this one because for one thing, I can see everything clearly. Manny, now you know the answer to that question. Will I take your final exam for you? That's like asking your professor, can they take the final exam for you? Come on, son. Thank you, Kiki Keisha. All right, Jose, I got you. Okay, here's the deal with these valence electrons. What you have to remember is that the group number tells you that, okay? So the group number tells you, like group 1 has 1 valence electron. Group 2 has 2 valence electrons. Groups 3 through 12, they have multiple types of issues, so we actually leave them out the equation. Group 13 has 3 valence electrons. When you get over here to groups 13 through 18, you drop the 1. So group 14 has 4, 15 has 5, 16 has 6, 17 has 7, and 18 has 8 valence electrons. Elizabeth, I'm rooting for you. I'm sending positive energy your way, love. You got it. All right. So what you've got here, okay? You guys are asking a lot of good questions. Make sure you all put those on my last videos though, okay? In order for me to know, because y'all got so many different requirements and requests. Now, if I do these videos for y'all, you got to come back and hit me up. You gotta say thank you. You know what I'm saying? So that way I know that you got it. Dalton's law of partial pressure. Yes, I'll do that one. I'll try to make a video for that one as well. I got a whole list of stuff. I got notebooks full of requests. Okay, notebooks full of requests. Okay. Woo. Okay, solubility too. Okay. Thank you, Uriel. Yes, I appreciate y'all so much. Y'all are showing so much love here. Yes, just put those things on put your questions on my last video, and I'll be able to do that for you guys. Oh, thank you. Thank you. Thank you. Yes, and you know, and like I said, I don't ask for much, y'all. If y'all can just tap that screen, all this free tutoring that I'm giving y'all, yes. Yes, yes, yes. Thank you, Diana. I appreciate the love. I don't know why I'm not on STEM Talk yet. Can y'all push that? Can y'all push me on STEM Talk? Thank you. Thank you. Yes. Okay, so um okay, so based on this conversation that we're having here, let me also say this too. When it comes to even writing out formulas, because I know someone had asked me about formulas, also remember the charges also are the keys to writing out the formulas too. Like all of this goes hand in hand. I promise you it does. Look, watch this. Watch this. Group one has +1. Group two has a +2 charge. Groups 3 through 12, they got multiple issues, so we're not going to give those charges right now. Group 13 has a +3 charge. Group 14 has a +4 charge. Group 15 has a -3 charge. Group 16 has a -2. Group 17, -1. And guess what? Group 18 is 0. Guess what? What's 7? Oh, well, before I get to the what's this? In chemistry, when there is a negative charge, we add. That means they have the ability to gain. To gain. I know it sounds awkward to think of it that way, but you know what? I don't know why the chemists came up with these awkward ideas, but yes. When they are positively charged, that means they have the ability to lose electrons, So think of it this way. If your checking account is in the positive, guess what? You can lose that money. But if you are in the negative, then you need to gain some money to get that back up. So what's 7 plus 1? 8. What's 6 plus 2? 8. What's 5 plus 3? 8. What are we getting at? They're all having the ability to take more to give them their full octet rule of 8. So when you talk about valence electrons and electron dot notation, that's what it's all about. That's what it's all about. So those that are positive, think about positive people. They're always giving to those people that are negative. It's almost like we're trying to calm down the negative energy, but the negative charge is always taking from the positive. The positives are going to always give. And the negatives are going to always receive. So what you've got here are those types of examples when it comes to writing out these formulas. Now, or doing electron configurations and valence charges. Now, just real quick, I'm going to give y'all 4 more minutes here, okay? If I were to write out the formula for, let's say, aluminum sulfide, okay? Aluminum sulfide. Here's what you've got. I know that aluminum is right here. It has a +3 charge, okay? So aluminum with a +3 charge. And then I know that sulfur is right there. And it has a -2 charge. So you know what's going to happen? Aluminum's going to take the 2 as a subscript, and the sulfur is going to take the 3 as a subscript. And that is your formula for aluminum sulfide. Remember, whatever you came into the relationship with, you're not going to walk out with when it comes to these formulas, okay? So in other words, if this is a formula between purple and black, when they switch charges, they're going to now have the new charge or the new element, okay? So in other words, I know that was probably like a corny way of saying it, but let me give you another example so you can see what I'm talking about. Suppose I gave you potassium oxide, okay? Potassium oxide. Well, in this particular case, potassium has a +1 charge. It's right there in group 1. Oxygen has a -2 charge. Oxygen has a -2 charge, and it's right there. So what are they going to do? They're going to swap charges, okay? They're going to swap charges. That I meant to put an O there. So K is going to take the 2, and O is going to take the 1. And you get a total knockout. I couldn't help it. I had to say it. K2O. Okay. So you get your formula for potassium oxide is K2O. So they swap. But the rule kind of flips when it comes to those elements that have more than one charge. And what I will do is go through those type of examples. I may just have to do a video just specifically on that, like some quick short videos that you can kind of just binge watch, like 30 seconds or less, or I would say 60 seconds or less. You know, do some shorts or something like that, where you guys can actually just digest, you know, a few examples in a short amount of time. I know this video on YouTube is going to be very long, but you can kind of speed it up. You can, you know, speed up the play, you know, maybe go like 1.25, 1.5, you know, if you don't want it to go too slow. Or you can pause it and see if you can solve the problem with me. Okay, guys. So, okay, EK said, where did the -2 come? I thought oxygen was 2, not negative. Okay, it's the ionic charges. So each element on your periodic table has an ionic charge, okay? They have an ionic charge. Ooh, that's a tongue twist. I got to go in the throat to pull that out. Ionic charge. Anything that has a positive charge, those are called cations or cations, you know, depending on tomato, where you're coming from. Anything that's negatively charged, those are called anions. So all of your elements on the periodic table have been assigned charges. And these are the charges that we kind of talked about a few minutes ago. Okay, so these numbers up here that you see, I actually gave those charges for each group of elements. Okay, Kate, you had a very good question. What's the difference between an ion and an atom? Ooh, good question. Good question. Check this out. K plus is called the potassium ion. But just regular K is the potassium. You can say potassium atom, or you can just say potassium. Most of the time, you're just going to say potassium. So an ion has a charge attached to it, whereas just a regular element does not. Excuse me. Okay. Yes, you're welcome. So cations and anions, it's the same thing. All right. Oh, good question. So if I have, let's say, chlorine with a negative charge, that would be the chloride ion. Ooh, I'm glad you asked that question because when it's negatively charged, when it's an anion, the ending becomes IDE. So chlorine is Cl, but chlorine with the negative is the chloride ion. Yes, he is, Glaze. Okay, covalent compounds. Covalent compound. Let me erase this stuff right here so I can address your concern. I said I wasn't gonna be in here for like 3 minutes, and now I'm on here longer. Okay, because y'all got questions and I got answers. Okay. So, covalent compounds. What are those? Those are, like we said before, non-metal to non-metal. So with covalent compounds and writing out the formulas, okay, if you have let's say CCl4, you have carbon, and then the formula for chlorine is tetra because you have four of those. So you have to say tetra in front of the name, and that's chloride. So whenever you deal with covalent compounds, you're going to call them like you see it with the numerical prefix in the name, like carbon dioxide, carbon monoxide. Now with Hess's law or Hess's law, I have plenty of videos on that, and you can actually get those on my TikTok channel or YouTube. Yep, I've done several of those actually recently. So you don't have to scroll too far to find those. The person that's spamming the comments with Hess's Law. I have those on TikTok and YouTube. You're welcome. I see it. I see your question. All right. So now, oh, I cannot believe I've been on here for over an hour, y'all. Oh my Lord. Okay, real quick. What about those with Roman numerals? Okay, Roman numerals, and that's how we're gonna close this one out. Roman numerals. Roman numerals means whatever the charge is, they're gonna tell you in Roman numerals. Okay. So that means if I say iron, Roman numeral 3, chloride, I'm going to say, all right, Fe with the +3 charge. That Roman numeral tells you the charge. I got you, EK. And then you're going to say chloride, Cl, with the -1 charge. So iron is going to pick up the 1, but the 1 is understood, so we don't have to write the 1 in. And then chlorine is going to pick up that 3. So FeCl3. You're welcome. Let me do one more as we close this out, as we close it out. What if I gave you copper 1? Oh, let me show you that one real quick. Copper 1 and copper 2, because there is a difference. Copper 1, you have to say Roman numeral. You have to put the Roman numeral there. You just can't say copper chloride. You've got to put copper with the Roman numeral because that's not understood. Okay, that's not understood. So copper has a +1 charge, chlorine has a -1, but the ones are going to cancel out. So you have CuCl. But if this was copper, Roman numeral 2, chloride, then you know what the answer would be, right? Copper with the Roman 2 has a +2 charge, chlorine, -1. They're going to swap charges. Copper's going to pick up that 1, and chlorine's going to take that 2. And that's your formula, CuCl2. All right, guys. So Professor TK, the chemist, has to rest her throat. I gotta let me clear my throat. And I don't want to do that on the live. So I will see y'all later. I might come back on tonight. I don't know. We're gonna see. I don't know. We're gonna see. If I'm not on tonight, I will see you guys most definitely on Monday. Monday. All right, guys. Thank you, Mariana or Mariana. I hope I'm saying your name right. I appreciate that so much. And you guys take care. And thank you, EK. Appreciate that as well. You guys are too kind, too kind, too kind. I appreciate the follows, the hearts. I appreciate it all. You have a great one too, Shohag, and I will see you guys later. You all take care and